Okay, 10.4 is all about hyperbolas, and these are also generated by two foci. In this case, we have 2 points, and then for this one, the difference of the distances from the foci is constant. So I'm going to go ahead and sketch a hyperbola. Hyperbolas will open, there's two pieces, and they will open around the foci, kind of like a parabola does. But in this one there are two. And then any point on the hyperbola, whether it's on the top branch in this case or the bottom branch, if we call our point on the hyperbola x comma y, the distance from the two foci, so here's, I'm going to call D1 the shorter one, so that's the distance to the closer focus, and D2 is the longer distance, then the difference between those two distances remains constant. So D2 minus D1 is going to be the same constant no matter what point you look at. So if I look at this one over here and I subtract these two distances, you'd still get that same number. Okay, so that's where hyperbolas come from. Excuse me. The way that we're going to kind of graph these is we're going to get the center, and we're going to get a and b values just like we do with an ellipse. For hyperbola, we have what are called the transverse axis and the conjugate axis instead of major and minor. So what we do is we take the a distance, and if this were, we'll talk about how to determine whether it's a vertical or a horizontal hyperbola. This one I'm going to just sketch as a vertical hyperbola. So the a distance would move in a vertical direction, and that's going to give us the distance between those two a values is going to give us what's called the transverse axis. Okay, is this whole thing. And then if we go in the horizontal direction, if we go to the right and left b units, that whole length is going to be called the conjugate axis. Okay, and that would go in the horizontal direction. If we make kind of a box out of those two lengths, this rectangle, if I draw lines that pass through the corners of it, are going to form asymptotes to our hyperbola. So the a and b values are going to dictate the shape of your hyperbola. So imagine if this a was shorter, both of these lines would kind of have a shallower slope, and the hyperbola would open wider. Whereas if the a was larger, they would kind of close up a little bit, and we'd have a skinnier hyperbola. Okay, so the way that I would sketch this, let me pick another color, sketch the hyperbola is it's going to pass through these points that are a units away from the center, and we're going to use the asymptotes, so we're going to get closer and closer to those lines as we move further and further away from the center. And then there will be one on this side as well. Or if this were a horizontal hyperbola, they would open left and right, and we would have to switch the a and b values. So the a values always go with what type of hyperbola it is. So if it's vertical, they go up and down, or if it were horizontal, it would go left to right. And then the b values always go with the conjugate axis. So those are kind of the other ones. We do call these points vertices, but notice that the b value doesn't actually result in a point. That's not on the hyperbola, so we don't call those co-vertices, although on the slide I kind of do. Those give us those points, but they're not points. I just have to remember that they're not points on the hyperbola itself, but it helps us sketch what it's going to look like. All right, so here are the two different forms that they'll take. If it's horizontal, you'll see the x stuff first, so it'll be x minus h squared, and if it's horizontal, that'll be over a squared, and then minus the y stuff, y minus k squared over b squared. and that whole thing is equal to 1. So it's similar to the equation of an ellipse, except that it has a subtraction, has a difference instead of a sum. Okay. If it's a vertical transverse axis, then the y stuff will come first, and that will be over a squared, and then the x stuff, so x minus h squared over b squared. Okay. In an ellipse, it doesn't really matter which one comes first because you're adding them, but with hyperbolas it does matter because the first term is positive and then the second term is negative. Okay, so I'm going to kind of sketch two different kinds, kind of in this style, but with the different a and b values. So for this first one, I'm going to sketch one with a horizontal transverse axis, which means it's going to open left and right. Here's my center at h comma k. The a value then would dictate how far we move in the horizontal direction. So this point over here would be h plus a, comma k, and the point on the left would be h minus a, comma k. And those are going to be vertices. Those are going to be the vertices of the hyperbola. And then we would also have the b values. So if we added b to k, this would be h comma k plus b. And the one down here would be h comma k minus b. And these are not on the hyperbola, but what it does is it helps me draw the little rectangle. And then the asymptotes that go through the corners. And then, oh, why did that get crazy? And then, what color do I want? And then we sketch the hyperbola through the vertices from there. It looks something like that. Okay. If it is a vertical transverse axis, here's my center at h comma k again. The a value then I'm going to move in the vertical direction. So we would go up a, and this point would be at h comma k plus a. And if we go down a units, this one would be at h comma k minus a. And then we'd move in the horizontal direction b units. So this point would be at h plus b comma k. And if we move to the left, that would be h minus b, comma k. Get the rectangle from there. Asymptotes. And this time it's vertical, so the vertices would be here, and we would open up and towards those asymptotes. Something like that. All right. So, as we've mentioned, the vertices are a units from the center, and then the foci, I can put these on here, are c units from the center. So, remember that our foci are going to be kind of on the inside of those branches of the hyperbola. Those are going to be right in the middle of where I wrote those points. But they're c units away from the center. So that distance would be c, or this distance would be c. And notice they go in the same direction as the a value or the vertices. So you'll hit the vertices first, and then the foci. And your c squared for hyperbolas is going to be equal to a squared plus b squared. All right, so let's do some problems. Find the standard form of the equation. It gives us our foci and vertices. So let's think about some distances. If I know where either pair is, either the foci or the vertices, we can find the center because it has to be halfway in between both of them. So using the midpoint formula or just thinking about what's halfway in between either of these pairs would be the point at 4, 0. So that's going to be our center. And then our foci are c units away from that. So our c value is going to be 4 because each of these points is 4 units away from 4, 0. The vertices are going to give us our a value, and the distance from these points to the center is 1 unit, so that's going to give us our A value, which is 1. We can find B from that. So C squared is equal to A squared plus B squared. So our B squared is going to be 15. I could take the square root of that, but I actually need B squared to be able to write the equation. So the other thing I need to know is which way does this open? Well, think about where these points are and tell me, are we going to have a horizontal transverse axis or a vertical? Go ahead and put that into the Edpuzzle. We are going to have a horizontal transverse axis because these points are left and right of each other. 0, 0, and 8, 0. Those are our foci. Then our hyperbola wraps around those, right? And we will have a horizontal transverse axis. So I'm going to use that first form where the x stuff comes first. Okay, we're going to have x minus the x coordinate of the center, which is 4, squared over a squared, minus y minus the y coordinate of the center, squared over b squared, and that's why I didn't need to take the square root, right? That's just 15, is equal to 1. And that's it. That's going to be the standard form of that hyperbola. All right. And one thing we can do, I have never memorized these, but it's been helpful in like maybe one Math Excel problem. I'm going to give this to you, but like I said, there's no reason to memorize it. To write the equations of the asymptotes, remember the asymptotes are very helpful for when we graph. And if we want to know the equation of those lines, we can do that, right? And this is where they come from. They're going to be y equals, and this is going to be k, and that should make sense because that's the y coordinate of the center, okay? And it's plus or minus, because there's two of them, and we do b over a, which should make sense because b would be like the rise, right? A would be the run, so our slope is b over a. We're going to have one on the positive direction and one in the negative direction, so plus or minus b over a times x minus h, and that's going to be the x coordinate of your center, okay? So this makes sense, but it switches. If we have a vertical transverse axis, it's going to be y equals k plus or minus, but if it's vertical, then the A is the rise and the B is the run. So this would become A over B and then times x minus h. So I typically don't memorize this, but there they are. Okay, so let's sketch some things. Let's sketch these hyperbolas. This one I can tell by looking at it, it's going to be centered at the origin, and that is because it doesn't have these like linear x and y terms that this one has. This one is going to be shifted where this one is not. Okay, to get this into standard form, I'm just going to divide all three pieces by 36 and then simplify a little bit. 4 over 36 will simplify just to 1 over 9. 9 over 36 will simplify to 1 over 4. And the right hand side just becomes 1. That's what we want. And we can get all the information from here. So our center is going to be at 0, 0. This is going to be a vertical transverse axis because the y piece is positive and the x piece is negative. The A value is going to be 3, B value is 2, and then I can find the C value from that. And the square root of 13 is between 3 and 4. I think it's about 3.6. Okay, when we plot those. Okay, so let's graph this thing. My center is at 0, 0. Because this is a vertical hyperbola, I'm going to go up 3 units, which is A. And then the B value is going to go left and right, so 2 units left, 2 units right. And then I'm going to use these 4 points to draw a rectangle. The rectangle is just here to help me draw my asymptotes. So my asymptotes are going to go through the corners of this rectangle and help me with the shape of my hyperbola. So it's going to look something like that. These points that we got from moving up and down A units are going to be the vertices. So those are going to be points on the hyperbola. And then just use your asymptotes to sketch these two branches. Get closer and closer to the asymptote as we move further and further away from the center. Whoa. So it's going to look something like that. And then because the C value is about 3.6, that means it's going to be about 3.6 units above and below the center. And so those will be right there. All right. Same kind of thing for B, but we're going to have to do some completing the square first to get this into standard form. So just like an ellipse, I'm going to group the X stuff together, group the Y stuff together, and move any constants to the other side. I don't have to factor anything out for the X's. That's ready to go. For the Y's, I want to factor a -3 out. So this will be Y squared. And then -6 divided by -3 will become +2y. And then I can complete the square for both X and Y. Half of 8 squared is 16. So I'm going to add 16 to both sides. For the Y's, half of 2 squared is 1, but I'm not just adding 1. This 1 does get multiplied by -3, so really I've subtracted 3. So I need to subtract it from the right side as well. Okay, and then rewrite this as the square of binomials. So the X will be X plus 4 squared, minus 3 times, and this will be Y plus 1 squared, is equal to 12 minus 3 is 9. I'm going to divide all three pieces by 9 because I want a 1 on that right-hand side. And that'll give me standard form. So X plus 4 squared over 9 minus Y plus 1 squared. That'll become over 3. I just simplified the 3 over 9. And then on the right we'll have our 1. Okay? Because the X stuff is positive and the Y stuff is negative, this will be a horizontal hyperbola. The center will be at -4, -1. My A value will be 3. B will be the square root of 3. And the C squared is equal to the squares of those two added together, so 9 plus 3. And the square root of 12 is just a little bit less than the square root of 13. It's about 3.5. Let me change that to approximately 3.5. All right, so let's graph this. Center, -4, -1. Now the A value is going to move left and right because this is a horizontal transverse axis, so 3 units left and 3 units right. My B values then are going to go up and down. Square root of 3 is about 1.7. And that'll help me with my asymptotes and my shape. So draw a box, and then the asymptotes through the corners. If your line's like a little wacky, like a little crooked, like mine do, maybe use a ruler. I could use a ruler here. And then, since I went left and right to get the A values, those are going to be the vertices of my hyperbola. And the C value is 3.5, so that'll be right kind of next to those vertices, and my hyperbola will open around them. And something like that. All right, let's write some equations. So here's some information about a hyperbola, and we're going to write the standard form. So we're given the vertices, 3, 2, and 9, 2, and asymptotes. Okay, so here's one of those ones where that equation of asymptotes can help. Basically what I'm going to look at is the slope. So I'm going to look at the vertices. If I go halfway in between the vertices, that'll give me the center. So 3 comma 2 to 9 comma 2, halfway between 3 and 9 is 6. So my center will be at 6 comma 2. And these points are horizontal of each other. So our hyperbola is going to have a horizontal transverse axis. The center from the vertices, they're 3 units away, so our A value is 3. And then let's look at our asymptotes. Our asymptotes are A over B or B over A. I can't remember. We could scroll up and look. But I know that my A value is 3. Oh, okay. Well, that tells me that my B value is going to be 2. Okay, and we could verify that if we look up at a horizontal transverse axis. We want to do B over A. And that's what we have. We have 2 over 3 would be B over A, so that's perfect. A and B, and we've got everything we need. So, because it's horizontal, I'm going to start with x. This will be x minus 6 squared divided by A squared minus y minus k squared over B squared equal to 1. And that is it. Okay, so that's really it for hyperbolas. The one last thing in this section is being able to determine what kind of conic you have when you are given an equation in general form. Okay, and this is when you just have everything multiplied out. I couldn't tell just by looking at this equation that it was going to be a hyperbola. Okay, they told me it was, so then I figured it out, right? But we should be able to tell, given this form, if an equation is going to represent what kind of conic. Okay. Notice that B is missing. We just have A, C, D, E, and F. So what the BXY term does is it is going to rotate our conic. And this is kind of that optional section we're going to do. It's in section 10.5. If the BXY term is there, it will rotate your conic. And there will be a different way to classify it. This method won't work, okay? But we'll get to that when we talk about that section. For now, though, the things that we can look at is if your A and your C value are the same, that equation is going to be a circle. If A or C is 0, okay, if you're missing the y squared term or the x squared term, that's when you're going to have a parabola. Okay, because you don't have both things squared in a parabola. You have the x or the y, but not both. So if one of them is 0, then the product is going to be 0. Okay, if the product of A and C comes out to be positive, meaning both your A and C have the same sign, so like they're both positive values or they're both negative values, you're going to have an ellipse. Whereas if they have different signs, it's going to be a hyperbola, because notice these ones here, not these, okay? The x and the y are opposite signs, right? We have one positive and one negative, and then here the y is positive and the x is negative. So if you have one of each, that's going to give you a hyperbola, but if they're both the same, that's going to give you an ellipse. So really just looking at the A and C values are going to tell you what kind of conic you have. Okay, so we'll just do that for a couple and then we'll be done. So for this one, the A is 1 and the C is -3. Those are different, so it's not a circle, and they are opposite signs too. Our A would be 1 and our C value is -3, which means this is going to be a hyperbola. Okay. For B, the coefficients of x squared and y squared are exactly the same, so that's going to be a circle. And go ahead and put the last two into the Edpuzzle, and we'll see how that goes. All right, I will see you back in Zoom.